Hello algebra students, here are your guided notes for 2.4 solving equations with variables on both sides. Now you're going to use a lot of the same concepts that we use from 2.1 all the way through 2.3. So some of these problems are going to seem similar or the same except for the fact that we have variables on both sides, hence the title of our section. Our essential question is that I can solve multi-step equations with one variable. So let's look at equation number 1, or example 1. I have 9z equals 4z minus 25. Now if I am going to write this out again here, I notice right away that I'm writing two different z's. I have my 9z and I have 4z. Now I don't need to solve for two different variables because I'm just going to solve for one. What I need to do is combine my like terms. So I have my like terms here of my 9z and 4z. Let's get them together on one side. They want to be on the same side. So what I'm going to do is subtract 4z from this side because instead of having to deal with negatives, I'd rather deal with positives. So let's try that. These cancel out. 9 take away 4, I end up with 5z. I drop down my equal sign. I still have my negative 25 over there at the end, still there. Now it's just down to a one-step equation. All I need to do now is just divide by 5 on both sides because I have 5 times z. I have to do the opposite function always. So instead of multiplying, I'm going to divide by 5. These cancel out. I'm left with z equals negative 5. I have a negative divided by a positive, so I know I'm going to have negative. 25 divided by 5 gives me 5. So I have negative 5 as my answer. Before you forget, make sure you guys put your name at the top there. I'm just going to put mine up there. That way you get credit for your work when you turn in your packet at the end of the week. Let's keep going on. I have 6x minus 5 equals 2x plus 19. Right away, I know that I have like terms. You can box them, put triangles around the lines that are like terms. I'm going to rewrite the equation right here. 6x minus 5 equals 2x plus 19. Let's combine our x's. So instead of taking away 6x from 2x and having to deal with negatives, I'm going to take 2x away from this side. What I do to one side, I have to do to the other. These cancel out. I'm left with 6 take away 2 gives me 4x. I bring down everything else that I did not deal with. I have positive 19 on that side. I don't need to be plus there, but I know that it's 19. Now I'm back to a two-step equation, just like what we were working on last week. This is good practice for this week again. Instead of subtracting 5, I need to add 5. If I add 5 to that side, I have to add it to the other side. These cancel out. I'm left with 4x equals 19 plus 5, 19, 20, 21, 22, 23, 24. I end up with 24. Unless you just know that right off the top of your head, that's fine. You can count either way is fine with me. I now have to just simply divide by 4. Divide by 4. I'm left with x equals 24 divided by 4 gives me 6. Sometimes, like in example 2, it's going to ask you to use the distributive property. The distributive property is just making sure that we multiply this 2 by m and this 2 by 3 here. Let's solve that right now. We're going to distribute this out. 2 times m gives me 2m. 2 times 3 gives me 6 equals 4m minus 4. I'm going to combine my like terms now. I have 2m and I have 4. I don't want to deal with negatives, so I'm going to take the smaller one away from the larger number. So I need to minus 2m from this side. These cancel out. I'm left with 6 equals 2m minus 4. Down to a two-step equation now. All I have to do is add 4 to this side. If I add 4 here, I have to add 4 over here. These cancel out. I'm going to rewrite it off to the side here, just since I have a little bit more room. 6 plus 4 gives me 10 equals 2m. Now I just need to divide by 2 because I have 2 times m. I have to do the opposite function always. Opposite of multiplication is division, so I'm going to divide each side by 2. 10 divided by 2 gives me 5. Those 2's cancel out. I'm left with m equals 5. You can cross off this equation. We don't like this one. It's dealing with a second variable that we don't like right now. So this is a no-go. So you do not have to do. Okay. Flip over to the next page, please. It should list at the top. It should say example 3. Looks like this page right here. Now this looks really complex right at the beginning, but it's really pretty straightforward, and it should go pretty quick for us as well. Now this is a special type of problem, so if you're trying to solve this through on your own, it might be a little bit goofy, so you need to make sure that you're following along with our notes here. Okay, let's try this. I have 7x plus 4 equals negative 2x plus 4 plus 9x. Since I have like terms on both sides, I need to combine them. I'm going to combine these two right off the bat because I know 9x take away 2x is just going to give me 7x plus 4. If I have 7x plus 4 on this side, let's combine like terms. Take away 7x. Take away 7x. These cancel out. But these also cancel out. This is what I'm talking about when I mean a goofy problem. I'm left with 4 on this side, I'm left with an equal sign, I'm left on 4 on this side. This is meaning that it is a true statement. 4 is equal to 4. I agree that 4 is the same number as 4. They are equal numbers. So we can have infinite solutions on these types of problems when they equal each other. Because no matter what we put in for x, if I put 5 in for x, if I put 5,000 in for x, they're still going to be equal to each other. Both sides of the equation are going to equal the same thing. So I have infinite solutions on these types of problems. Okay? These are special problems. Okay? Now, if we look down below, I have another special problem here. This one's a little bit different though. Let's try it. I have 5x equals 9 minus 10 plus 5x. I see like terms. I want to combine like terms. Let's try that. I'm going to take away 5x from this side, take away from this side. Huh, that's weird. I get 0 equals 9 minus 10. And I know that actually 9 minus 10 is actually going to be negative 1. 0 is equal to negative 1. That's just not a true statement. So this is not true. Or we can state this as no solution. These are, again, a special problem. You will see problems like this in your practice, so just make sure you're careful of this. If you don't see it today, you will see it later in our week. Last example. This is a consumer application, so this is something that you might actually use an algebra equation for in your day-to-day life to try to figure out which option of a plan or coverage might be cheaper for you. In this situation, it's talking about a wireless plan for phone calls. Okay, back before there was many companies that did unlimited everything, a lot of times you'd be charged by the minute. So let's read through this example. Okay, example 4. The long distance rates of 2 wireless phone companies are shown in the table. How long is a call that costs the same amount no matter what company is used? So we need to find out how long that call is, okay? And what is the cost of that call? So we need to find out at the same amount for both of these companies. So what I can do is make sure that I'm going to find out what A is first. So A's total price is 10 cents per minute. I'm going to use M for minute. Per minute. I also have a $40 plus charge. So you're going to also add 40 plus. Since I'm using cents, I'm going to put 0.1 for 10 cents. Now this one is 15 cents per minute. Plus a $35 charge. If I want to find out how much each of these are when they are equal to each other, I have the same variable. I'm gonna set them equal to each other in this situation. So I have 10m plus 40 equals 0.15m plus 35. Let's combine like terms. I have like terms here and like terms here. I don't want to deal with negative numbers, so I'm going to take away the smaller number from the larger one. These cancel out. I'm left with 40 on this side equals 0.05m plus 35. I'm going to take away 35 from here, so I just have a two-step equation now. I'm left with 5 is equal to 0.05m. Now I just need to do some division because I have 0.05 times m, so I just need to do some division here. So if I am going to divide this here by itself, so it cancels out, I have to divide the other side by 0.05 as well, because what I do to one side I have to do to the other. So I'm left with 5 divided by 0.05 gives me 100 m. Okay, so 100 m. What is m again? Minutes. So how long is a call that costs the same amount no matter which call, which company is used? So a 100-minute call. Now, what is the cost of that call? So let's plug in 100 for each, whichever one we want to. I'm going to do it for this first one. Doesn't matter which one you choose. 0.10 m plus 40. That's my equation from here. You can also use this equation. They should equal the same. So now instead for m, I'm going to have 100. If I do 0.10 times 100, I end up with 10. And I'm going to add 40 to it. The cost should be $50. Now to double check to make sure that I'm right, I'm going to also use this equation here. I'm going to plug in 100 for m in this situation also. .15 times 100, 0.15 times 100, 15 plus 35. I know that 15 plus 35 gives me 50. The call would be $50 for a 100-minute phone call with either company. This is the end of your notes for the day. Once you finish with these guided notes, make sure you flip over to the next page. On the next page, you have 9, 10 problems to do. Okay, sorry, this one is a 13 there that has a misprint. Make sure you're combining like terms. Okay, make sure you're looking for those special problems that we talked about in the notes. This problem down here, problem 13, make sure that you're setting them equal to each other. That was what we did in example number 4. If you have questions, make sure you rejoin the Google Meets or you send me an email and work out another time to meet with me. Thanks, guys.